Automated machines changed manufacturing forever when they began assembling parts. CNC assembly machines have taken automation to the next level. CNC is an acronym for Computer Numerical Control. The machine is automated by computer rather than by mechanics. To design a CNC assembly machine, engineers first analyze the sequence of tasks required to assemble the product. They then match each task to a pre-designed processing engine. The processing engines are linked together in a custom assembly sequence. Each engine is programmed to control its computer-guided motors, which perform the precise motions required to execute a task. The CNC machine's engines are mounted on a sturdy base frame. To construct it, workers cut steel tubes to the required lengths. They grind a joint in each piece. Then weld the pieces together by melting steel welding wire into the joints. They bolt a steel tabletop onto the base frame. It has cutouts for each engine. It's been ground perfectly flat so the engines will be level with each other. Meanwhile, an electrical technician is assembling the machine's main control cabinet. It contains one industrial computer for each engine. A CNC machine has engines for performing rotary movements, linear movements, and for picking up and placing parts. The motors inside each engine have their own computers. They're programmed to perform movements at specific speeds and forces. Once the main control cabinet is assembled, workers bolt it to the base frame. Then they install steel bases for the engines. Some CNC machines require robotic arms. A computer-guided milling machine cuts rectangular bars of aluminum, shaping them into robotic arm components. This precision measuring device ensures each milled part meets strict specifications. After the aluminum components receive an anti-corrosion coating, workers assemble them into a robotic arm. These self-lubricating sleeve bearings give the arm the ability to rotate. They add a second assembled arm to create a pair that works together to perform an assigned task. Each arm is controlled by its own motor, which follows the commands of the engine's computer. This coupling securely connects each robotic arm to the shaft of its motor. Each engine on the machine can have up to 8 motors. The motors can operate independently or in unison. This engine has robotic arms that can pick up, hold, and release parts. To test the completed machine, a high-speed video camera captures images at 1,000 frames per second. The quality control team slows down the video to analyze and fine-tune the accuracy and efficiency of every motion. Just a few simple taps on the operator's touchscreen can adjust the arm to move a millisecond faster or a millimeter further. CNC machines can assemble small products at high speed. They also provide something traditional assembly equipment can't: flexibility. A single machine can be reprogrammed multiple times for assembling different products.